Hi guys, in today's lesson, I'll be teaching us neutralization reaction and oxonium ion. If this is your first time watching my video, I want you to subscribe to my YouTube channel and also follow my Facebook page at Brainwave Online Chemistry Tutorials. So let's get started. If you have not watched my previous video on acid and basicity and also alkali and acidity, I'd advise you guys to watch those my previous videos so that you get the real gist about acid, basicity, alkalis, and acidity. So let's get started. Now, neutralization reaction is the process whereby an acid reacts with an appropriate amount of alkali to produce salt and water only. So I come again. Neutralization reaction is the process whereby an acid reacts with an appropriate amount of alkali to produce what? Salt and water only. So I'll be defining it mathematically on the board right now. So neutralization reaction is defined mathematically as this: the process whereby an acid reacts with what alkalis to give us what? Salt and water only. So these are the only products that are being formed under what? Neutralization reaction. So the process of acid and alkali reacting to form what? Or to produce what? Salt and water only is what is referred to as what? Neutralization reaction. In my previous video, I talked about acid. I talked about the types of acid that we have, which is the strong acid and the weak acid. In also one of my previous videos, I also talked about the type of alkalis that we have, which is happen to be what? The strong alkalis and the weak alkali. Now, before we take some of the example of this, I will quickly talk about some of the examples of acid that I gave my previous video and some of the examples of alkalis that I gave my previous videos before. So we have types of acid. We have two types of acid, which happen to be what? Strong acid and what? And weak acid. Now, strong acid are acid that was ionized completely in solution or dissolved completely in solution. Watch down my previous video to get the full gist on acid. Now, we also have some of the examples of what? Of strong acid, which include, we have hydrochloric acid. So one of the examples of strong acid, we have what? Hydrochloric acid, which is happen to be what? HCl. We have tetraoxosulfuric acid, which happen to be what? H2SO4. So these two are some of the example of what? Of strong acid. We also have what? Triiodnitrate acid, which happens to be what? HNO3. So these three are some of the example of what? Strong acid. Now we're not talking about weak acid. Weak acid, they are acid that what? That ionize slightly or partially in solution. Now, example of weak acid that we have ethanoic acid. We have what? Ethanoic acid, which has the molecular formula of what? CH3COOH. Ethanoic acid. We also have triiosocarbonate 4 acid. They happen to be what? H2CO3. So these are some of the example of what? Weak acid. We also have tetraoxophosphate 5 acid, which happens to be what? H3PO4. Tetraoxophosphate 5 acid. Now, we're not talking about what? The alkalis. The same way we have what? Two types of alkalis. We have what? The weak alkalis and the strong alkalis. Now, weak alkalis, they ionize completely or dissolve completely in solution to produce what? The hydroxide ion. If you have not watched my previous video on my YouTube channel, please, I advise you guys to watch that video so you can get the full gist on what? On acid and alkalis. I just brought out this out so that when we are reacting some of the equations, you guys will know what I'm doing. Now, like I said earlier on, we have two types of alkali. We have what? The strong alkalins and the weak alkaline. So under alkalins, we have what? Strong alkaline. Strong alkalins. And what? Weak alkaline. So we have what? Strong alkaline and weak alkaline. Now, strong alkalins, they are alkaline that what? That dissolve completely in solution to produce what? The hydroxide ion. alongside with what, with metallic ion. But our major focus is what, is the hydroxide ion. Just like our major focus under acid was the hydrogen ion. That's the same way under alkali our major focus is what, the hydroxide ion. Now, examples of strong alkali that we have sodium hydroxide. Example of strong alkali, we have what, sodium hydroxide, which happens to be what, NaOH. Also have potassium hydroxide, which happens to be what, KOH. So these two are some of the examples of what, of strong alkali. We have what, potassium hydroxide, sodium hydroxide. Now we now move to the weak alkalis. Now the weak alkalis, they ionize slightly or partially in solution to also produce what, the hydroxide ion alongside with the metallic ion. Now some of the example of the weak alkaline, we have aqueous ammonia. Aqueous ammonia, which has the formula of what, NH3.H2O. We also have calcium hydroxide. Calcium hydroxide, which is happens to be what, Ca open bracket OH subscript 2. So aqueous ammonia, calcium hydroxide happens to be what, some of the examples of weak alkali. Now, have we brought out this out? Now, going back to neutralization reaction, I said earlier on that neutralization reaction is the reaction of what, an acid with an alkali to give what, salt and water only. So these are the types of acid and these are the types of alkalis that we have. Now we'll be taking examples. Now we'll be taking what, some examples under what, neutralization reaction. We'll be taking some examples under neutralization reaction. Now let's take an equation to represent this. Let's see if truly this is correct. Now let's take an acid, for example, like hydrochloric acid, which happens to be what, HCl plus alkaline like sodium hydroxide, a strong alkaline, NaOH. Now once they react together, what, please don't forget that the products that we form in neutralization reaction happens to be what, salt and water only. Salt and water only is the only product formed under neutralization reaction. Now acid and alkaline, they are both what, reacting together. Now the product that be formed is what, salt and water only. Now what will happen here is this: there'll be exchange of what, of radicals. Now this sodium ion here will now react with this chlorine ion here to form what, the salt. Then this hydrogen ion here will now have to react with what, the hydroxide ion here to now form the water. I'll explain again. Now what will happen here, this sodium ion here will pair with this chlorine ion here, while this hydrogen ion here will now have to pair with this hydroxide ion here to form what, the water. So the salt that will be formed here will now be what, the sodium chloride, which is NaCl plus hydrogen ion plus hydroxide ion will give us water, which happens to what, H2O. So this is what neutralization reaction is talking about. When an acid reacts with an appropriate amount of alkali to produce what, salt and water only. So this is what neutralization reaction is talking about. Now the sodium ion is reacting with the chlorine ion to form what, the salt, while the hydrogen ion will react with what, the hydroxide ion to form what, one molecule of water. Here now we have two atoms of hydrogen. We have one atom of hydrogen here, also have one atom of hydrogen here. Now once the two pair together, we now have what, two atoms of hydrogen. Don't forget we have one atom of oxygen here, we also have one atom of oxygen here. Now one sodium here, one chlorine here, one chlorine here. Now please, when balancing chemical equation, so I'm diving a little bit now into what, chemical equation. Now when balancing chemical equation, please take note that the number of mole at your reactant side will equals what, the number of mole at your product side. Now let me also say this. Now when balancing chemical equation, now the variable or the value we're giving at your left hand side is called what, the reactant. So your acid that is reacting with your alkaline is known as what, the reactant. It's not what, the reactant. Now your product, now this other one that is being formed at your right hand side is called what, the product. It's called what, the product. So your reactant, they react together to form what, your product. So the acid and the alkaline happens to be what, the reactant, while the salt and the water happens to be what? Our product. So this is what neutralization reaction is talking about. Now let's take another example under what neutralization reaction. Let's take potassium, and let's take another acid, for example, triazonitrifide acid, which happens to be what? Triazonitrifide acid, which happens to be what? HNO3 plus potassium hydroxide and alkali. Now, this is another example. Now, let's take a look at this. Now, in this case, triazonitrifide acid is reacting with what? With potassium hydroxide. Now, anytime acid is reacting with an alkali, please take note that the products that will be formed will be what? Salt and water only. Please take note that the product that will be formed is what? Is salt and water only under what? Neutralization reaction. Now in this case, what will happen here is the same thing. Now, this sodium, this potassium, this potassium ion will react with what? With this. Now, there's what we call acid radical. There's what we call acid radical. Now, acid radicals, they react with what? With hydrogen ion to form acid. Now, this will be another teaching of another day. Now, this potassium ion here will have to react with this NO3. This NO3 here is an acid radical. So we react with this NO3, which happens to be the acid radical, while this hydrogen ion here will now have to react with this hydrogen ion to now form the water. So now our answer will now be what? KNO3 plus the hydrogen ion is reacting with what? Our hydrogen ion. So now get to our water, which is happens to be what? H2O. Now, acid radicals, they all have their own charge. Like NO3 here is an acid radical, and the charge of this NO3 here is 1 minus. Now, what will happen here? And potassium here is the what? In group 1 of the periodic table. And since potassium is the group 1, please note that group 1 of the periodic table, they have a charge of what? Of +1. Now, potassium here is what? Is +1. And what? NO3 here, which is an acid radical, is what? 1 minus. Now, +1, 1 minus is what? Equals 0. Minus means you are owing. Plus means you want to pay. Now, +1 minus 1 is what? Equals 0, which means that this place is what? Is balanced. Now, we have what? Now, we have one atom of hydrogen here. One atom of hydrogen here bonded with this oxygen atom. Now, we combine this hydrogen here and this hydrogen, this hydrogen ion here and this hydrogen ion here to form what? One molecule of what? Of water. Now, we now have two hydrogen here. If you look at it here, there's one here, there's one here. Look at the two hydrogen here. Then we have one oxygen here. Look at the one oxygen here. Then the acid radical that's here. Then the acid radical that's here. If you check, you see that the values at the right hand side and at the left hand side, they are what? They are both balanced. So this is what neutralization reaction is trying to talk about. When acid reacts with what? An alkali to form what? Salt and water only. So this is what neutralization reaction is just trying to talk about. Now, moving on from here, we'll be moving straight to what? To oxonium ion. We'll be moving straight to what? To oxonium ion. Please, if you don't understand, let me know in the comment section below. So from here, we'll be moving straight to what? To oxonium ion. Now, what are oxonium ion? Oxonium ion, they are ions that are being formed when hydrogen ion. When what? Hydrogen ion. When what? Hydrogen ion react with 1 mole of water. React with what? 1 mole of water. So this ion is being formed when hydrogen ion reacts with what? 1 mole of water. So mathematically, it is expressed as this. Oxonium ion is formed when it is represented as this. When hydrogen ion reacts with what? 1 mole of water, which is happens to be what? H2O. Now, when hydrogen ion reacts with what? 1 mole of water, oxonium ion is being formed, and it's written as this: H3O plus. Now, if you look at it very well, we have 2 hydrogen here plus this hydrogen ion here. That makes it what? 3. 1 oxygen, 1 hydrogen. Please don't forget that the charge must be written because it's an ion. Ion, they always have what? Charge, either positive or negative. So don't forget that the charge must be written at the top right hand side. So I repeat again, oxonium ion is being formed when hydrogen ion react with what? 1 mole of water. So that's how oxonium ion is being formed. Now, the bond that takes place when hydrogen ion reacts with 1 mole of water to form this oxonium ion is called what? Coordinate covalent bond. Please take note of this. Coordinate covalent bond. Coordinate covalent bond. Please take note that the bond that takes place when hydrogen ion reacts with 1 mole of water is called what? Coordinate what? Covalent bond. So the bond that takes place between the two of them for the oxonium ion to be formed, please we should take note of this bond. Now, please we should take note that the oxonium ion can also react with what? And hydroxide ion to form what? 1 mole of water alongside with the salt. Please take note of this, that this oxonium ion here can also react with what? With hydroxide ion. So let me represent it mathematically. So H3O plus can also react with what? With an hydroxide ion. To form what? To form water, which happens to what? H2O. Now we'll put 2 here because to make it balanced, because we have 3 hydrogen here plus 1 hydrogen here, which happens to what? To be 4. Now, if I erase these 2 that was here before, now we have 2 hydrogen here, making it water. But we have 3 hydrogen here plus 1 here, 4. Now, how do we make it 4? By putting 2 here. If we put 2 here, now don't forget that this 2 that is acting as a mole here is also affecting this oxygen. But if you come back to this place, we have 1 oxygen here, we also have 1 oxygen here, making it 2. Now this 2 is for the hydrogen also, and also for what? For the oxygen also. Please, we shall take note of this. So this 2 times this 2 here will make it 4 hydrogen atom here. Then this 3 hydrogen atom plus this 1 hydrogen atom here, now make it what? 4 hydrogen atom here. Then we have 1 oxygen atom here, 1 oxygen atom here, making it 2 oxygen atom. Then this 2 is affecting this oxygen also, making it what? 2 oxygen atom here. Now, this can also represent what? Neutralization reaction. Please, you should take note of this. Now, this can also what? Represent neutralization reaction. Now, a salt is also being formed along. Now, we can also define neutralization reaction as the process whereby what? An hydrogen ion is being reactive with what? With an hydroxide ion to form what? To form water alongside with what? With a salt. Please, we should also take note of this about what? Neutralization reaction. So let's look about what? Neutralization reaction. Now, neutralization reaction can also be defined as a process whereby an hydrogen ion is being what? Reactive with what? An hydroxide ion. So it is represented mathematically as this. When what? Hydrogen ion is being reactive with what? Hydroxide ion to form what? 1 mole of water, which happens to what? H2O. Please take note of this, that what? Neutralization reaction can also be formed when what? Hydrogen ion is reacting with what? Hydrogen ion to form what? 1 mole of water alongside with what? With a salt. So with this, we have come to the end of this class. Please, I want you guys to what? Subscribe to my YouTube channel, and also what? Follow my page at what? At Brainwave Online Chemistry Tutorials. So thank you guys for watching to the end of this class.